Yay. So a lot of these terms you've had before, right through elementary school in 7th grade. So some of these terms are going to be relatively easy for you to get, and you'll be happy for them. So the first one is an angle that measures less than 90 degrees. This is an angle that measures less than 90 degrees. We call it acute. It's probably the most joked about angle in math.
Maybe we heard.
Because it's very punny. So angles in the same plane that have a common vertex, we're going to get to what a vertex is, and a common side. So when you draw angles, I've got two angles. These angles are what we call adjacent. Hopefully I spell adjacent right. So these two angles are adjacent. They share a common side and a common vertex. The vertex is that point where they come together. That's the vertex. And they're adjacent because they're literally side by side. Why do I need to know terms like adjacent angles?
Other angles?
If I talk about one angle and I say the angle adjacent to it, you can refer to whatever's next to that first angle. So a pair of angles on the outer side of two lines cut by a transversal that are on opposite. Now, we're going to talk a lot about parallel lines cut by a transversal. So a pair of parallel lines, they go along, they have the same slope, right? A transversal is any line that transverses it or goes across it. So what we're talking about is a pair of angles on the outer side of two lines cut by transversal that are on opposite sides of the transversal. We call those alternate exterior angles. When we're talking about parallel lines cut by a transversal, every reference we make is going to assume that interior is between the parallel lines. Does that make sense? And exterior is things on outside of the parallel lines. These two angles, this angle here and this angle here, are on the outside. They're external angles, and they're on opposite sides, or alternate. Does that make sense? Okay, a figure formed by two rays with a common endpoint called a vertex. What is this?
Angle.
It's an angle. Two rays with a common endpoint called a vertex. Okay. Two triangles that are similar. If it can be two triangles are similar if it can be shown that two angles of one triangle are congruent to two angles of the other triangle. So this one's saying this. If I have a triangle and I have another triangle and I say this is angle A, that's A degrees, and this one's B degrees, and over here I say this is A degrees and this is B degrees, how many total degrees are in a triangle? So if both of these have the same angles, even though they're swapped around, there are...
The same.
It's a postulate called angle-angle similarity. Angle, angle, did I spell similarity right? Yep. Similarity. Angle-angle similarity. It means that two triangles are similar.
Cool.
Now, similar means contains some of the same properties or the same ratios. These two triangles don't have to be the same size. One could be enormous and the other small, but because their angles are the same, their proportions will be the same. Does that make sense? It's just one's an expense of the other. All right, two angles whose measure have a sum of 90 degrees. So I've got a 90 degree, which we don't, and I've got two angles. And their measure total is 90 degrees. They're called complementary.
Did we give compliments?
Yes.
Well, first I better go.
So complementary angles are two angles who together become 90 degrees. Do complementary angles have to be adjacent angles?
No.
No, they just have to be two separate angles that add together to make 90 degrees. They can be far apart of the circle, but if they add together to make 90 degrees, they're complementary.
I go.
Thanks. Okay. Having the same size and shape. It's a math word called congruent. So when something is congruent to another thing, they are the same size.
Wow.
If we get out two iPhone 11s and put them side by side, they are congruent because they're the same, right?
Unless I have a case on.
Now,
Sorry.
why did you introduce the kit? Why did you have to go ifing? Avoid the urge. Just take a simple example as a simple example. Now, they're congruent compared to similar. All congruent objects are similar to each other because they have the same proportions, right?
Yes.
But are all similar objects congruent?
No.
No, because similar can mean bigger or literal. It just has the same ratios and proportions. Does that make sense? So angles in the same position formed when a third line intersects two lines. You recognize that? So these are angles in the same position. See those two angles? They're in the same position. You see them? Yeah, these are our parallel lines cut by transversal, right? Look at these two angles. This one goes from here to here, and this one goes from here to here. They're called corresponding angles. Tell me something you notice about corresponding angles. What are they also? Which is, what word is that in math?
Congruent.
Congruent. Corresponding angles are congruent. They equal the same thing. They're also similar. An angle on the outside of a polygon. So a polygon is any shape I want, and I'm going to make my polygon kind of a rectangle. So I've got interior angles, right? This is called an exterior angle. Whoops, can't spell angle. Exterior angles become super useful with triangles. Because we know that when you add, if you've got a line and there comes an angle to it, the two angles that meet to make that line make up total of how many degrees? How many degrees in a line? 180. So if I've got an exterior angle that's 105, all I got to do is to find the interior angle, subtract 180 from 105, or 105 from 180, and I get that interior angle. Does that make sense? So exterior angles are super useful. In a right triangle, the side opposite the right angle, it's the hypotenuse. Hypotenuse or hypotenuse. It's the hypotenuse.
Just like saying the word.
Yeah, I spelled it wrong too. This is not hypotenuse. or the hypotenuse. If I was a better artist, I would do the hippo. So a hypotenuse, you've got a right triangle, and this is the hypotenuse. Now, why is it important to know where the hypotenuse is? We're going to get into right triangle theorems, and there's a bunch of them. The Pythagoreans sat around and came up with a bunch of rules, and you get to learn one of those, Pythagorean Theorem. So the hypotenuse is also the longest side of a triangle, and that helps us do it. You guys see hypotenuses every day. You don't even know it. Every time you look at somebody's roof, you're looking at two hypotenuses.
Huh?
Well, think about it. When you look at a roof,
There's one on each side.
you've got this, right? You're looking at two hypotenuses that make up a roof. So roofers, when they need to know how long or the roof is, they can get up there and measure it, or they can measure the up, down, and across the house and come up with a hypotenuse pretty fast, which saves them from standing on the roof looking stupid or falling through. What is the angle on the inside of the polygon called? So before we had a polygon, we called it a rectangle. What's this one called?
Interior.
Interior angle. It's inside with the air conditioner. So an interior angle is the angle on the inside of the polygon. We're going to talk a lot about interior, exterior angles, especially with triangles. Okay, everyone, am I going too fast or is everyone following along?
I think we're doing pretty good.
So, in a right triangle, the sides that include the right angle. So, in a right triangle, the sides that include the right angle, that's these two sides here, right? They're called legs. So, every time you look at a right triangle, you can say, wow, look at them legs! And you'll be okay.
He's not okay.
Math jokes. Alright. An angle whose measure is greater than 90 degrees but less than 180. Obtuse. That's one of those good ones that you know already, an obtuse angle. It's somewhere between past 90 and less than 180.
Didn't we learn this in like 5th grade for that one?
Mm-hmm. Some vocabulary, and it's going to keep coming up. Like I said, right now, we did the volume, we did area, and now we're doing angles and triangles. This is your introduction to geometry.
Great.
So, lines in a plane that do not intersect.
Parallel.
Parallel lines. They have so much in common, it's a shame they'll never meet. Such a sad math story. They were parallel lines. Doesn't that make you sad?
Not really.
Not really?
It makes me happy when I get to quit doing parallel lines.
Nah. An angle that measures 90 degrees. A right angle. So it's an angle that measures exactly 90 degrees, and we do that with a little box in the corner. That just saves from ever having to write 90 there. Shorthand for 90, right? Little square. You got all this written? All right, now the little sheet.
Oh, how cute.
Caitlin's watching this online. At some point in the future, she's going, oh my gosh, 2 sheets? Hi, Caitlin. A triangle containing a right angle. What do we call a triangle that contains a right triangle? It's a right triangle. So, figures with the same shape but not necessarily the same size. I already told you the phrase. What is it?
Uncongruent.
No, you can't have uncongruent. Similar. Similar. So I might have a square that's this big and a square that's this big. They can be similar. That means all the angles match, all the proportions match, but they're different sizes. Two angles whose measures have a sum of 180 degrees.
Wait, what?
Two angles whose measures have a sum of 180 degrees. Think about this.
Oh, it's a straight line.
No. Two angles whose sum, it does make a straight line here, but this is 180 degrees, right? Mm-hmm. They're called supplementary. Supplementary angles. All right, so a line that intersects two or more lines. I've done this before. I put these out here. I put parallel lines, right? And I intersected them. This line here is called a transversal. Because it transverses a line, which means to cross over. Mm-hmm.
This one's out.
Why are you telling me that right now? Did it have anything to do with what we're doing? Okay. So all you had to do is throw the pen away, right? And get a new pen. But we're not doing that right now. Okay, the sum of the angles measured in a triangle is 180 degrees. This is something called the triangle sum theorem. Theorem. In math, especially in geometry, there's a bunch of postulates and theorems. A theorem is something that's proven to be true over countless attempts. And a postulate is just below that. A lot of times once they call something a postulate, it just stays that. So things that, when I was a kid, they called a postulate are still postulates. Even though it's been proven to be true, it continues to be true. They don't change it because we got all these things printed that say it's a postulate. Does that make sense? So we're going to look at a couple of them. This is the one that says the triangle sum theorem says all the angles inside a triangle equal 180. If you add them all together, they equal 180. We're going to do another one called the Pythagorean Theorem. Yes, that one's going to be big. And the Pythagorean Theorem says the square of the legs, the sum of the square of the legs equal the square of the hypotenuse. So the last one we got here is the point where two sides intersect on an angle or a polygon. So it's that intersection.
Vertex.
The vertex. So, any questions on the terminology? We're going to be using a lot of them. You guys need to know that two angles or supplementary angles equal 180 degrees, and they make a line. Complementary angles equal 90 degrees. Do supplementary or complementary angles have to be next to each other to be supplementary or complementary? No. To be supplementary, I just have to have two angles that equal 180. To be complementary, I just have to have two angles that equal 90. They don't have to be anything else special about them. Does that make sense? We're going to look at angle-angle similarity, and that one's pretty common to see. Where you've got two triangles, and you'll have to calculate, do they have two angles that are the same? If they do, then they're similar. And that goes with all the triangles equal 180. It's going to be similar. Does that make sense? Any questions on this so far? Wesley, you're completely distracted. Did you get all this written down?